Kind of meetup, please get in touch with either myself or Dario. It's important. It takes time every month finding a venue month on month. So it's a little bit that you can contribute to help out. Hugely appreciated if you can. Just get in touch with Dario. Other than that, welcome. I'm obviously on the meetup group. Those of you who are at your first Microservices meetup, quite a few of you this evening. Hopefully I've sent most of you a welcome email. If you are attending Microservices for the first time, and having spoken to a few of you, there are a lot of people attending their first London meetup or new to London, then I'd like to very briefly introduce Megan, who runs a group called Meetup Mates. And I won't steal your thunder, Megan, you tell everybody about Meetup Mates.
Hi, so I'm Megan. I'm the community advocate at TechNovo, and I'm currently looking after Meetup Mates. So Meetup Mates is the community initiative that's both offline and online to make attending meetups a little less daunting. So we meet an hour before the meetup at a nearby venue and just all arrive as a group together, so not arriving not knowing anyone or knowing where the venue is or anything like that. You can sign up at meetup-mates.com, where we have our Slack channel where you can find out what meetups are happening that you're interested in, see who else is attending, and just learn what's happening in London. So I hope to all see you at the next event. Woo!
Matt, you're up. Oh,
sorry. I was expecting someone else to tackle that. Sorry. Just enjoying that. Okay, sorry guys. A quick corporate one, obviously. Blackrock talked about these things. So welcome Blackrock. Thanks for coming. All seasonal greetings. I'm going to refer quickly to this slide, not go over it in any detail. I think it's fair to say that just to highlight Blackrock, it's often a firm that people don't know. I know when I went through financial crisis, my mum thought I worked for Northern Rock. Not true, I work for Blackrock. I had to explain the difference. I think some interesting numbers on here. It's quite nice to write the word trillion up on a slide. The one that actually I found more interesting was the relied on by 60 plus of the world's largest tech and financial institutions. So it's quite an interesting one. I won't go into too much detail now, but we're really looking to solve a lot of these sort of significant challenges, which is kind of the reasons why we're really interested to listen to a lot of the talks and learn from forums like Microservices London. So there's lots of people in the room that actually watch these. There's a number of people in the room from Blackrock. I won't make them put their hand up. They should be relatively easy to solve, because the ones that kind of know where the toilets and the beer is. But we'd love to learn from you more about how you're doing it and the problems that you're solving, because I think these are problems that we're trying to solve now, and we're in this business together. So thanks very much. Love to talk to you guys all later. Enjoy the evening. Thank you.
Thanks, Matt.
Cool, so here's the program for tonight. I'm Dario. I'm one of the organizers of this meetup. I'm more on the technical side of things, so I kind of talk to the speakers before they speak. I kind of point them in the right directions and make sure that the presentation are fit for the audience that we have here, and give feedback and that sort of stuff. Because I'm a techie person, and what all is was responsible for finding the venues and sponsors and that sort of stuff. Tonight we have two talks. This is usually the same. We always follow the same structure where we have half an hour at the beginning and we'll network, and then there are two talks, half an hour each and 10 minutes for questions at the end, and we have 5 minutes in between. So yeah, the first talk is going to be by Christian, a fixer, and he's going to talk about something that I find very interesting. I've been running this meetup for a long time, and I think too often we talk about the positive things of microservices, and I think it's very important to talk about what is not very good, but also quite often we talk about similar things, and I agree with Christian on the fact that there are a lot of benefits that a lot of people don't talk about, don't think about. So I actually very excited about this talk. So it's really good. So yeah, Christian, I need you. So it's going to take about 10 minutes. Yeah. Magic button.
Right. So this talk is actually just a step back to the basics of microservices, and I lost my speaker notes. Perfect. And for those of you that are really unsure about microservices, don't know if you want to do them yet, you don't know what they're about and what are the advantages and disadvantages. And also for those of you that need extra arguments to convince your boss or your friends to move away from the evil monolith. And it's written from our perspective, a young startup, about 3 years. So it's also coming from the recognition that we as a community that love microservices, we often rush to praise scaling as the main, if not the only benefit of microservices. And while scaling is absolutely great, we need to admit that it's not necessarily interesting for all projects or the only option that we have to achieve scaling. So there are many examples of big corporations that achieve great scale with just more standard tools. So I remember when Stack Overflow, they reached a few hundred million requests, and they were doing that on 2 web servers. So I'm gonna, actually, my name is Christian, which doesn't really work, but I work for a company called Fixter, and we're basically the delivery of car servicing. So you book online, you pick a slot, somebody comes in and picks up your car, drives it to a garage, gets it fixed, then gets it returned. Now, what stands out about this kind of business is that there are many parts to it, from the customer app, driver app, garage apps, to driver fleet optimization, to quotation engine, and so forth. And they all scale at different rates. So for example, the driver tracking will produce a lot more data than the garage ever will. So this is why actually we picked microservices when we started about 3 years ago. And 3 years later, if you would take away the advantage of microservices that we get for scaling, we would still do microservices. And here's why. First one, really basic and obvious one, it's component decoupling. So everybody agrees that you need to decouple your architecture. Even monolith people want to decouple the architecture. And if you are going to have a tightly coupled architecture, it's going to cost you. So eventually it's going to cost you with cascading technical debt, eventually with your team sanity. So yeah, you really want to decouple. But microservices is not the only way to decouple architecture. You can do it in a monolith. However, in practice, in over 10 years of doing this, I have rarely seen it work well, especially in an early startup, because the business pressure is just too high. So the temptation is too high. You can save so much work by just leaving a bit of implementation information over here. You can create that circular dependency over there. So always you have this temptation to tightly couple your components. And I am a firm believer of the mantra that just trying harder doesn't really work. So what you want the system to help you along with this. So you want to remove barriers from your development team, and you have a setup. You need a setup to nudge you in the right direction at every step. Right? And microservices can be that. So they create the proper frame of mind to think about your software. And there's many ways to implement this. I'm a big fan of event systems and data pipelines, and that can sometimes be quite scary for some people. It has a high cost, both in terms of knowledge and sometimes in money. But you don't need to use a full-blown Kafka implementation to start. You can start simple. So we have, for a long time, we just used SNS and SPS, so the simple notification service, simple queue service in Amazon, and only recently moved on to Kinesis, but that transition was really simple because each component was using the right concepts. Now, there's obviously dangers, and I think even with the right setup, the temptation is still there. So you need to be very careful, because you can end up with tightly coupled microservices, which honestly are worse than a monolith, because they work and fail together, and you get the worst of both worlds. You don't get any advantage, and you get all disadvantages. So this is why actually I would recommend that if you are getting started with microservices on a big project, you do want to have that expertise in the team. You want to have somebody that already knows about these dangers and how to overcome them. If you can't do that, simple rule of thumb that I use sometimes, you can always ask yourself, how would I build this service if I would have to share it with a third party? If I would sell this as a separate revenue stream, how would I build this? So for example, if you're building an address microservice, right? How would you build that if you would know that another entity would also use it to store and to do lookups and to basically store it? You wouldn't store it against user ID, right? You'd make it more generic, and you would decouple it in a way. All right, number 2. I think microservices are an excellent way of improving your security. In particular, they help you reduce surface area of attacks, and they hinder exploitation cascades. So what I mean by reducing surface area, like you will have the minimum amount of code exposed to the public. If you have a vulnerable package that is inside the microservice that doesn't have to be exposed to the outside world, it's going to be less dangerous than being in the big monolith that is entirely exposed to outside. So in fact, a key concept in security is minimum necessary permissions. This is giving a person or a tool a minimum amount of permission necessary to do their job without hindering them. So this applies to developers, this applies to system administrators, applies to case managers, and applies to your software. So microservices are great at helping with this. Here's a few things that we do. First of all, we run each service in an isolated environment. So if this is Docker, if somebody gets into a microservice, it doesn't necessarily attack the other parts of your infrastructure. We give each service the minimum permissions to shared resources. In Amazon, you do that with IAM. And so for example, this means access to S3 buckets or SNS topics. And it's really easy to do. You just give them the minimum amount of permissions for each service. And then you can give minimum amount of firewall permissions. So in Amazon, this is very easily done with security groups. I was talking to a security researcher, and saying there's nothing more annoying than when they manage to finally get in a system, and then they can't download the scripts that they need. So you can very easily set in and out firewall restrictions for each service individually. Ideally, each service should have its own database, but sometimes you can end up operating with a shared database. And in these cases, you want individual users for each service. So not only they have different passwords that you can evoke separately and you can rotate separately, you also can give minimum amount of permissions for each service. So if you don't need to write on that table, don't give it right on that table, right? Or drop. And also, what we do is inter-service authentication. So if somebody gets past your authentication gateway, you just can't run rampart and calling everything in your network. Now, again, there's a danger here. Even with all of these benefits, I think it's still more likely that if there's going to be an attack, it's going to be due to a basic mistake. So don't forget the basics, right? And in particular, microservices don't help you with this because there's more projects, there's more opportunities to make mistakes. So, for example, we have over 150 GitHub projects, for each service. And one common problem we noticed was that if a service was stable and we didn't need to update it, it would keep those stale dependencies, and we didn't update it. So another problem with this is that you will probably have multiple teams working on different services, and they might all have different standards. So what you want to do is very early on create standards for all of your services, and the basic stuff. So no tokens in GitHub. Don't burn down the house. Encrypt your secrets. So now we have very good tools. For example, for encrypting secrets, we're using parameter store with KMS and Amazon. You could use Vault from HashiCorp, which is an excellent tool. And another thing we do to help, we download the configuration at runtime, again, powered by IAM permissions, so you don't have out there a build artifact that contains all of your secrets, and that can leak out. We also need to rotate your secrets. Nowadays, we have Secret Manager on Amazon that does that automatically for you. And as I said, update your old packages. Now, GitHub gives you this for free, notifies you, just need to act on it. And Snake is also an excellent tool to help you with keeping your entire dependency tree up to date. Number 3, increase resilience to defects. So what I mean by that is that microservices contain failures. Again, the key concept is well-defined service boundaries, not just leaking implementation details, but just not sharing infrastructure between these services. So this will prevent you from having cascades of a failure. The same way it prevents security breach cascades, it will prevent just failure cascades. So for example, well, first of all, how do they do this? It's just simple. It's less complex with a clearly defined role. There's simply less that can go wrong. If one of your services crashes, then it doesn't take down your entire infrastructure. Right? It restarts, and you'll have one service that out for a bit. It also will help you identify bottlenecks easier. So it will make that easier to do. For example, we had a tricky memory leak at some point. I don't know if it would have been, probably would have been complicated to debug, but it was plainly obvious that it was coming from the PDF generation microservice, because that was just growing the memory usage until it would crash and then would get restarted and so forth. Right, so again, dangers regarding this. Microservices won't make it easier to debug certain types of bugs. So pay extra attention to service coordination. Some things that will be harder to do is database transactions. You're gonna have to find alternatives for that. And there's a particular set of bugs that don't show up when you're individually testing your service, but might show up when you have different microservices working together, like coordination issues. The good news is that if you're using microservices, you're probably already thinking about good architecture, right? So you're already thinking from the beginning about graceful degradation, about try logic, about self-healing. And nowadays you have like amazing tools to help you with that. For example, AppMesh, which is a tool built on Envoy, it integrates with Amazon services and keeps track of all the communication between your tools, and you can define policies for failover and things like that. I think in Google Cloud, it's called Istio now. So it's a similar thing that helps you with that. Now, one metric that we have, and wasn't planned at all, but we're quite proud of it right now. 100% of new joiners in our team deploy something to production the first week. And part of it is because the continuous integration, because of 5 different levels of testing, and because we have a great team. But part of it is because we trust in this resilience to defects. Okay, number 4, easier to experiment and evolve. So we all know that in order to keep a team agile, and we need to grow our skills. We need to develop new approaches to problems. We need to experiment. And for the project health itself, you want to refactor, upgrade, update of dependencies, libraries, and approaches. So I think microservices give you a safe space to experiment, and that which is very important. So it allows you to try new technologies, try new libraries safely, even different programming languages, and it allows you to do gradual refactoring. So you don't have to do the whole monolith at once. For example, when we started, we were using plain vanilla JavaScript, and then we had the hackathon and we experimented with TypeScript. We all liked it so much. We built it for one service only, a mini service. It worked great. We showed the fact that we had 20% less bugs on that service, and then we gradually upgraded each service one by one. When we needed to update something in a service, we also refactored it in TypeScript. That you don't have to do that all at once. Now, again, dangers. You can go crazy with trying new stuff. So if one person is trying to use a esoteric programming language, you need to ask yourself who will maintain that. So what if the original creator leaves? What if he's on holiday? Who will maintain that code base? Obviously, you need to get the balance between experimentation and keeping it maintainable. Okay, 5, easier versioning. So microservices can help you with that. In particular because it allows you to do individual versioning of the different services, and you can also have easy to multiple deployments. So, for example, if you have a if you have a monolith, I'm a big fan of backwards compatibility, but sometimes it's too expensive to be worth it. So, what do you do in a monolith if you want to introduce a second version of an API that is not backwards compatible? So you have two options. You can have 2 or 3 versions running at the same time. You can and then you update all of your clients. It gets complicated if you have the entire dependency tree of those APIs, like using incompatible versions of libraries. It gets complicated. And you can just disable the old API and move all the clients to the new one, but you don't have control always on who your clients and what APIs they use. Plus, you can't do that without downtime. And with microservices, that becomes easier because you can do multiple deployments, or you couldn't deploy the monolith multiple times, but that gets expensive in terms of resources. Right? So with microservices, it becomes easier because you can have multiple deployments with different versions, with an entirely different dependency tree. Number 6, another obvious one, probably the most obvious one. You get faster build time, build, deploy, and test times, actually. There's less code. There's less code to compile. There's fewer tests to run for each unit. There's less infrastructure changes to manage at each deployment. So we use Travis and GitHub Actions. It's not particularly fast tools, but and with Terraform as well. And still, we get amazing deployment time. So when we started 3 years ago, we had the MVP built with Monolith. Now that had significantly less features than what we have now, and still the whole build, test, deploy process took more than 30 minutes. And imagine you're fixing a critical bug. You want to get that out as soon as possible. So right now we have averaging at about 2 minutes their build and test, and then we can deploy it automatically. And with some services, I get getting under 1 minute for this, so that's great. Okay, and another obvious one, fewer conflicts. Again, obvious. You have less code, allows for more parallel working. When we started, we had a serious case of code spaghetti. You've seen those dependency trees in GitHub where we don't know what's actually going into this release or what isn't, right? So microservices can help with that. We haven't had a serious case of spaghetti in over 2 years. And let's look at a few disadvantages of microservices. As much as we love them, we need to recognize the limitations in order to be better prepared. So, say problem number one is they tend to aggravate premature optimization. So this is actually a serious problem that can kill a startup. Some call it the root of all evil. So it's easy to look at the big company and hear a story about how they were using a monolith and they had to spend millions to change their entire architecture to use microservices. But we don't know what the past would have been if they would have started microservices from the beginning. Maybe they wouldn't have taken off in the first place. So we shouldn't be quick to judge. We should be careful about not implementing something until we actually know it. Problem number two, improved debugging complexity. So even though these days you have great tools like AppMesh and X-Ray in Amazon, it is harder to debug. It is harder to do integration tests, and it is harder to track down an issue. So we need to recognize it. And lastly, you do need extra expertise when you get started. So it's more expensive to get the knowledge that you need, and it's more expensive to learn about microservices, and it's more expensive in the first few steps than if you just build a simple application on monolith. And sometimes that can be a tricky. So in conclusion, that microservices are not a magic solution. They don't solve everything, but they do. But I think they do force a shift in thinking, and that helps with component decoupling. I think they improve your security by allowing you to do minimum permissions per service. I think that clearly defined service boundaries improve reliability, and they reduce build time complexity and conflicts when developing, and as well as fostering experimentation and growth within your project and your team by allowing you to gradually upgrade to new technologies. That's it. Anybody has questions? It was really basic. So.
This question may be too more off topic, and so feel free to decline. But you mentioned that sort of, or you alluded to, thinking that sort of debate on a service gets its own database, maybe it's not technical, maybe they have their own users. You heard about it when we got to this idea of services get their own tables as scripting, of course, or is that really relevant?
Yeah. As I mentioned, so we started with an MVP that was a monolith, obviously had a shared database. So then when we gradually migrated, because moving from a monolith to microservice is basically like driving at 80 miles an hour and trying to change the wheels while you did, especially if you have something in production. And the way we did it is we first kept that shared database, and we tried to restrict each service to one table, and only created one user with specific permissions and access to just that table.
Did you follow the fact that with microservices it's way easier to start another project or just add another service to be an advantage or kind of to be a disadvantage of microservice architecture?
It's both. It's both an advantage and a disadvantage. It's so easy, especially after you get started and you create like a boilerplate for your service, and you don't have to create all the setup. So now we can start a new service by just running a CLI, and it gives you the basic stuff. It's very tempting to start something new, but the problem is you need to remember that you have to maintain that. So there's a lot of there was a lot of discussing and creating standards within the team to know who owns what service and how do we maintain them. So most of the time it's great because you want to start something new, just build it. You know you need to build it, but you need to have a discussion within the team about maintenance as well. It's going to get worse.
In terms of creating and maintaining the pipelines, like build pipelines and deployment pipelines, is it maybe just the software developers at your company that do that, or do you have people that specialize?
We do have a QA department, but we hired automation engineers, and when we hired them, we said the job is not to test everything. The job is to improve the knowledge within the team and help everybody know how to test better. So it's something that everybody does it. I did say there's 5 different tests or types of tests that we do. There is one that is done by the QA department, but everything else is done by the entire team.
If you can go back to day one, you just go monolith first, get framed.
Depends how much time you have. Now, I would say right now, with the knowledge that we have gained, probably not. Probably we'll start microservices first because we kind of know where the pitfalls are and we know where we could have done better and we know what we should have avoided. But if I would start over with the knowledge I had then, probably yes, probably I would do monolith first.
Would there be any circumstances in which you would consider a monorepo, for example, being a better option than individual repos?
Yeah, I know people that are doing this successfully. We don't. To be fair, we always wanted to try. I don't know personally if it would be better for us. Maybe we'll try it at some point, but I know people that are doing this successfully.
With separate, like build pipelines for separate projects, or
no, I think they have the people that know have a single pipeline for all of the services at once. Yes.
How do you share data between your microservices? So for example, if you have a microservice that, let's say, handles all the customer data, and another one handles all the purchases, and the third one handles the payments, and you need to run a query that says, find me everyone in the last 48 hours that's made an order of this size and hasn't paid, for example. How do you run that across 3 databases without literally doing, join basically between the tables?
Yeah, it depends for what you're doing this. Oftentimes, what you're describing is necessary for reporting. And for that particular case, we actually have a pipeline that takes the data and moves it into BigQuery. And we use a separate database for reporting queries. Because first of all, you want protection. You don't want your reports to destroy your production database. But secondly, it makes this easier. If you need it for live features, something that you need in production, you just build the APIs that allows you to put the Lego together. Microservices are Lego basically. So we use GraphQL in some cases that allows you to mix and match different APIs of these microservices and get into that.
But if you did have data in 2 separate places and you wanted to join it at scale, would you kind of loop through and do N+1, or would you?
No, GraphQL now can solve N+1. You can do batching within.
Probably the data is
Not really. Maybe if you give me a specific example, or maybe you can talk about it.
How many microservices are you running on your system? How do you define what your microservice is going to do when you decide to go down that route and design your?
We're getting into the dark arts.
It's a big. But no, roughly, how many have you got and sort of what are you
We
doing?
have 100 plus
Yeah.
at the moment. Depends how you define it, right? So we, majority of our services are actually running in, with ECS, which is the equivalent of Kubernetes from Amazon. And we're running my majority of those in Fargate, so we don't care about infrastructure. But we also have things that we run in Lambdas, things that have a very unusual usage pattern, things that you have a spike of hundreds of thousands of requests at once, and then the rest of the month you don't actually have anything. So I guess you can consider each Lambda a microservice in that case. I guess you define it if you can create a logical separation, and you can think of a case where that can be used by multiple parts of your product. Or, as I said originally, if you can think that that is something that somebody outside your company would actually make use of. But it's up to the individual, but if you can create a clean separation.
You mentioned that one of the problems that you could encounter is managing dependencies, especially when you get into like tens or if not hundreds of microservices. And based on, like in my experience, when you're working in kind of microservice infrastructure, a lot of your services can have the same dependencies. And obviously a monorepo is a really easy way to solve this.
Yep.
But I wonder, have you guys come up with a way to maybe how do you maintain those dependencies if you have to update a dependency in 100 different microservices at once?
Well, we've been lucky that in a sense we kind of constantly update all of, or majority of them, so that every time when we touch something, we also update dependencies. But I can imagine scenarios where you have a service that you don't touch for a very long time, so then that would become a problem. But I don't know if monorepo would solve that. As I said, sometimes actually you have a dependency, a microservice that depends on a dependency at a particular version, and that microservice is running perfectly fine. And you need to update that dependency in another part of your system because you need a new feature, for example. But now suddenly you're breaking this other service. Like why do I now need to fix this other service if it's working perfectly fine? So I guess advantages and disadvantages. I don't have to fix without a monorepo. I would update everything at once, which is great. Without monorepo, I can pick what to upgrade when. Yeah.
You said that you changed the wheel of the car by moving from monolith to microservices. I mean, after having done all that, how much time do you think you lost? If you were continuing on the monolith, you would have probably gone to a certain level of development. But moving to microservices, you probably lost 20% of the time to build it at the same time, but you slow down the car a little bit. So how much you estimate for your project?
Well, the great thing about microservices is that you can pick what you separate out. It's in a way, it's like, okay, I know that I need to upgrade this functionality. Why don't I just get all of that code and try to put it there? It might go through a transition period where you're sharing a bit of infrastructure, but then you can carve it out. So I don't think we lost too much time. Obviously, there was some time lost, but we looked at what was coming and what was the roadmap, and we knew that at some point, if we continue on the path we were at the beginning, we would have had to stop, get the whole team to go into this rewrite project, and that can kill business, right? So we prefer to, okay, lose 20%. I don't know if it was 20%, 100%, but you lose some speed, but that allowed you to continue.
Yeah, extending maybe on that, is there a case, and is that the case with you, that you can have long-term a shared infrastructure with a bit of monolith and some other microservices? Because as you said, microservices don't solve everything, and it might not be the right solution for everything. So could it be that in the same company, you have a bit of both?
There's definitely possible that through a transition period. I don't know if I would recommend that for long term. You can certainly do it. It's just, I'm thinking that the biggest problem is the difference in approach and having to continuously switch between, okay, I'm thinking about doing this way, and now tomorrow I'm working on this other thing, I'm doing it this other way. Might not be the most optimal way to work in a team. As I said, you can certainly try it. There's certainly a problem with microservices that sometimes we actually split them too much. It is a problem that we're trying to break. We're doing this entity that doesn't make any sense without this other entity, but it has its own service. So that is a danger. We don't want to fall in that trap. But I would say if you have a single team working both in monolith and in microservices, there's a completely shift in thinking that you need to allow for. Yes?
Is there any product or product type you wouldn't recommend to with microservices? Let's say, I don't know,
I'm sure there is a product out there that is not suitable for microservices. I don't know which one. I haven't met it yet.
All right, cool. If you have any more questions, you can just.
Yeah.
All right,
Thanks, everybody.
Take a 5-minute break and went through a big journey with them about the good things about it. Cool. Hey everyone, can you hear me? Yeah. So I'm Robert from Gusto, and yeah, today's talk is really a peek into Gusto's journey so far, from small startup to scale up, and really focusing on our microservice architecture. I think not everyone is lucky enough or unlucky enough, depending on how you look at it, to experience the pain that you go through as a scale from small startup. So yeah, I want to give you a rough idea today of some of the issues we had and the approach we've taken to for the rest of our journey, the rest of our scaling journey, to make it less painful. So what are you going to learn from my talk today? So I guess to answer that, and just have a quick show of hands of who's working with microservices in production.
Yeah, I've worked.
Cool. And just a quick show of hands, keep your hands up if you've got hundreds of microservices in production.
Right.
Mostly good stuff. So yeah, I guess what I'm going to talk about today is really the pain that you feel when you go from a couple of microservices, which I guess most of you use, to running hundreds. I mean, I'm not going to talk about anything revolutionary if you already work with microservices, but what I hope you take away today is why the architecture we had, especially in the early stages, slowed us down and made our scaling painful, and how we've really taken some well-known ideas, some of what Christian already talked about in the industry, and we've adapted them into sort of good principles that we want to follow to help us scale. I think most importantly, I find I learn best when I take ideas I hear and adapt them to my context. So hopefully you'll go away from here as well with some ideas about how you better scale your own technology, your own team, your own business. So a bit about me. So I joined Gusto in May 2016. I've worked in a lot of various engineering roles since then, both hands-on and hands-off. So I joined as a senior engineer, did a bit of line management. I worked mostly as an architect. And yeah, I've been working with microservices for about 7 years now, but I've learned the most I've learned about microservices at my time in Gusto. And
and I mean, I used to think that microservices, I think most of you obviously understand this already, but microservices, I used to think that they're a problem, or they're a solution to the problem of scaling your technology. But I think what I've learned most, and I think someone mentioned it last meetup, if you guys went to it, is that microservices are really a solution to scaling teams and scaling people. And that's really what the crux of my talk is going to be about. So I guess to set the context, I'll briefly talk about what Gusto does. Normally I ask this question the other way around, but who is not heard of Gusto or what we do? Okay, yeah, so we're growing. So yeah, Gusto is the largest recipe box company in the UK. So recipe boxes, you go on the website or app, you choose some recipes, and we send it to you in a box with the exact ingredients. So we're really trying to reduce food waste. We started in 2012. We did a roll over the UK, 7 days a week, and we're doing next day delivery now. But I think the key metric I want to highlight is since 2016, roughly when I joined, we've grown 15 times in revenue, 10 times in terms of our technology footprint and our team, and every 1 in 1,000 dinners eaten in the UK today is a Gusto. So yeah, you might be wondering what tech does in Gusto. I guess the short answer is everything. Everything that we do, pretty much everything that we do is powered by tech we build in-house. So starting from our e-commerce website and apps, to everything like our recipe development tooling, our order fulfillment pipeline, warehouse management, optimization, a lot of data science like recommendation, menu planning and forecasting, it's all done in-house. And we do it all in-house, and I'm sure if you run your own businesses, you know, to develop your own software and iterate on it rapidly gives you the competitive advantage over using off-the-shelf products, which takes a long time to customize. All of that functionality is powered by a large variety of microservices that we've built up over a couple of years. And yeah, before I go into the meat of my talk, I really want to give you I guess an insight into the journey we've been on. So December 2013, we actually started off with a monolith. That's when our monolith was created. Back then we had 2 engineers, so very, very small team. Yeah, you can't even call it a team, 2 people. So I guess it didn't really make sense at that time to go crazy with distributed systems. And yeah, by the way, that monolith still exists. I won't talk about the monolith today, but that monolith still exists. In 2015, the mid-2015, we really started investing in some of the foundations that we need to lay to go into microservices. That's about the time that we hired a VP of engineering, and he really led the initiative into introducing modern development practices and deployment practices. So yeah, infrastructure as code, CI/CD pipelines, doing immutable deployments, all of the good stuff that you need to do microservices well, or deploy microservices well. We didn't have any microservices at this point. We were still only deploying a monolith, but what this allowed us to do is go from deploying a monolith, which took 2 hours, I think, of downtime to deploy once every sprint, to deploying multiple times a day. A few months later, we went live with our first microservice in production, and we roughly doubled the team in size then. And we come to today, where we've got over 100 microservices in production, and we've got about 50 engineers across 8 teams looking after those. Yeah, a lot of those, I guess, 100 plus microservices that is mentioned, they were built up quite organically over time. And if you let things grow organically, you end up with something that looks a lot like this. Yeah, and I don't think anyone who's running a business at scale wants to be navigating architecture that looks like that. So to really give you a feel of what that organic growth looks like, I'm going to try something that I've never done before. I have no idea how this is going to work. We're going to do a live design exercise. I'm going to try and cap it to 5 minutes, because I know if you get engineers designing stuff, it can go on forever. But yeah, I want you all to pretend you're engineers at Gusto. I'm going to take you through a simplified part of our platform. I'm going to bring up a blank canvas of Google Draw, and I want you guys to tell me what to build in about 5 minutes. I'll try and steer the conversation. I think it's a bit slow. By the way, if you do this well and if you're looking for a job, invite engineering managers here. So cool. Cool. So yeah, the part of the platform that I want to look at for this exercise is how a recipe appears on various parts of our platform. So a recipe starts off in development as a test recipe, and our recipe developers use the tool to sort of play around with it, add ingredients, see how it works. Once they're happy with it, that recipe appears in our menu planning tool, and that gets added onto weekly menus that appear on our website. At the same time, that recipe also appears or is available for curating into our cookbook, which is a separate part of our website, which is mostly used for SEO traffic. So if you go into Google and type in a recipe, you might see one of the top links being a recipe booster. You can go and click on it and learn more about the recipe and go and order it. And then once you see a recipe on the menu, you can place an order, you can add it to your order, and then you can see it under the My Orders on My Orders page when you log into your account. And then also, when you place an order, you get an email with the details of the order and the recipe. So, let's see how this is going to work. So, I've got a blank Google canvas, Google Draw canvas. I've given you a starting point, recipe development tool. We've got some building blocks. So, red blocks are front-end components. Grey blocks are back-end microservices. Red arrows are API requests. Grey arrows are events. So yeah, no idea how this is going to work, but let's see. Can someone start? Where would you start? You've got a recipe development tool, developing recipes. What do you need? Okay. So I guess let's have an ingredients service. Cool. How do they communicate?
We're on the back end of it.
Sorry?
We're on the interface.
I guess we don't need to go into detail. I guess we've got the interface. So we've got recipe development tool. I guess you can see the ingredients there. So obviously you can choose your ingredients. I guess I imagine you'll have some kind of API request going there. Yep. I guess once you've created it, once you've chosen some ingredients, what do you do with it? You create a recipe. Where does that live?
Recipe API.
Okay. Doing better than I thought. Cool. We've got a recipes API. What would you calculate? I guess you could have that on the front end if you need to. Yeah. Cool. All right. So
well, actually, I think it's more of a what's the endpoint gonna be? If you're gonna recipe is like which recipe you want. So that recipe gonna be the endpoint in the recipe development tool, and then it's gonna communicate to the various endpoints.
Yeah. Yeah. So I guess on the recipe development tool, you have a dedicated endpoint for a recipe that you want to develop,
so
and then when you save it, that will save it to. It'll make an API request to save it to.
So let's say if I want to develop pizza, the endpoint gonna be the pizza in the recipe development tool, then it's gonna interact with the ingredients and the recipe methods and some other microservices, and then it's gonna come up with a combined result, then gonna return to the user.
Okay. So I guess let's add some arrows. Okay, I think let's simplify. Let's focus on what we've got here. So we've got some recipes. We save them. They need to appear on the menu, on the cookbook, in your order, and in the order placed email.
So maybe
Okay.
When a new recipe is added, you want to notify the menu service.
Okay, cool. So we have a menu service. Cool. I guess you notify it through some kind of event. Yep.
Something to do with seasonality and availability.
I think you can assume that's contained within the menu planning service, so that works out what recipes are best for this time of the year. So I guess you've got the menu part of the website. So
how about the reporting?
There was also the cookbook aspect, right, where you want the particular recipe to go for the cookbooks and all
Yep.
the separate service.
Okay, so we've got a cookbook. cookbook service. How does the recipe go there?
So APIs push them when a new recipe is created, maybe it would like to them driven somehow, or Facebook technology or something like that.
Cool, yeah. That way, just to simplify things, comes the time to want to cap this. I imagine you have something similar for orders.
Good enough recipes.
Yeah.
Kind of thing, and now like whoever's interested, pick it up now.
Yeah, yeah, yeah. So yeah, I guess just fast forwarding, you've got.
Have we kind of decided that pushing the recipes is the best idea rather than these services querying? Because most of those services will probably need to know about a recipe anyway.
What do you think?
I think on the menu it kind of makes sense to go and query the recipes at that point in time rather than the menu storing its own local copy of recipes.
Okay, yeah, yeah, that's a fair way to look at it.
I think the recipe would just publish, and those points, like the cookbook, menu, and orders, will subscribe to whatever engine, and then it will just, once it's consumed, then it will basically destroy that event.
Yeah, I think, cool, let's go to time, I'm going to move on. This is great architecture. I guess what I'm going to show you next is what we actually have. Cool. Back to start my presentation. Cool, so we've done the live design exercise. Yeah, so what did it actually look like? Yeah, as I said, red boxes are front-end components, grey boxes are back-end services, and red arrows, API requests, grey arrows are events. So we had a recipe service. Again, it's a bit simplified. I won't go into that level of detail that we had before. We had a recipe development tool that wrote recipes to this recipe service. Then we had the menu that, as you suggested, queried the recipe service directly for recipes. We had the cookbook page, which had a cookbook service. Then that queried recipe service to get recipe data. And we had the orders page, which had an order service, but that also queried the recipe service to get recipe data. And then we had an event that triggered the email. So yeah, I guess, what's wrong with this?
Follow the arrows.
Sorry?
Follow the arrows.
Yeah. I guess, I mean, to start with, there wasn't much wrong with it. At the scale we were, and the size of the team we had at that point, it worked perfectly fine, and we didn't see anything wrong with it. But yeah, as we started to scale, that's when we started to see problems. So yeah, we've got some tightly coupled chain dependencies to fulfill a request. We've got something that's doing way too much, single point of failure. And what isn't obvious here, but as we scaled and we added more teams, we split the ownership of this. So what that created was like hard dependencies between teams. Yeah, what is make scaling painful? So we've got tight coupling, chain dependencies. That you've got a really brittle system there. So if one part of that, I guess, chain dependency fails, the entire chain fails. Or if you make small changes to one part of that system, it affects the rest of the system. That's really brittle, catastrophic way. We've got single point of failure. So as long as you've got systems depend on it, falls over on the load, site basically stops working, which happened to us. And it's obviously doing too much. You've got a lot of messy code, confusion of responsibilities, you're slowly ending up with another monolith. And we have split ownership. So having those dependencies manageable, then it's all under one team, but as we scale, we split the ownership of those services without actually breaking those dependencies. And all that did was it really reduced the autonomy that our teams had, and that slowed us down a lot. So what does it look like now? Somewhat, because we're really on a journey to get to a better architecture, and it's still a work in progress. We've got a recipe development tool. We've still got a recipes service, which is master of recipe data. We've got a dedicated menu service, which you guys came up with, and the menu talks to that directly. And we've got dedicated cookbook and my orders services that the front-end parts of the website talk to directly. We've still got these back-end services for managing cookbook groups, managing orders. But crucially, the difference here is no service talks to another service directly using API requests. It's all using asynchronous events. And really, I guess to understand this architecture in a bit more detail, I'll talk about some of the principles that we came up with to evolve our architecture. So, first principle that we have, I think someone asked this question, is how you decide what microservice is. This is a question we try to answer. So, first principle is we've got three flavors of microservices. So, entity services for simple domain entities like a recipe or a cookbook group. They're either master of entity data, and usually they've got some kind of dedicated tooling for simple CRUD operations on an entity. We've got feature services. So, for example, looking at your orders, browsing the menu, these services are optimized for that feature, both in terms of how they scale and what data they store and how they store that data. You've got dedicated feature front ends that interact with that feature. You've got workflow services, trigger some kind of workflow like sending an email through an asynchronous event. The next principle is asynchronous by default. So any communication between one or more backend services should always be asynchronous by default and using events. There can be some exceptions, which I'll just mention in a bit. So we use events and message queues with a PubSub architecture. So we actually use SQS. We're not at the scale we need to invest in something like Kafka cases yet, but using events and message queues. And the third principle is data bulkheading. So different people call this different things. I've heard it's called data de-anonymization, for instance, but essentially it involves services pushing data they own to other services that need the data. Every consuming service has a copy of data it needs, so it doesn't have to make any API requests, and it has everything it needs to fulfill the request. That data might not necessarily be up to date, which was what thanks. So yeah, go back to this architecture. Those are our entity services. These are our feature services. We've got asynchronous communication with data bulkheading, so pushing data to features that need them, using events. Yeah, that's the architecture we're going towards. It's a little bit simplified. Grouped things like separate read and write services that form this sort of menu service, for example, but you get the general idea. So I guess why are these principles good? Why have they made scaling easier? So if you start with three flavors of microservices, it really allows us to think quite granularly about how we want to slice functionality and have well-defined boundaries and responsibility between services. And that allows teams to own more of their vertical or whatever functionality they're looking after and reduce the dependency between them. Asynchronous by default, so obviously services still need to communicate with each other, but by making them asynchronous, they're coupled more loosely so that any changes that are made between dependent services don't have an immediate or critical impact on them. And using data bulkheading, we basically completely remove operational dependency between services. They've got everything they need to fulfill a request. They don't need to talk to any other service other than their own database, and less likely to have single point of failures that take the whole site down. So things you need to keep in mind: eventual consistency. Seeing on microservices before, eventual consistency is basically the state of your data across your systems might not be the same at any given point in time. That's something that comes with the territory if you're using events and doing data blocking, especially for example. So the full principle that we have is asynchronous by default, synchronous when necessary. So if you've got critical functionality where you need the latest state of the data, you can make a synchronous request, but it's by exception, and Obviously, you need to make sure that whatever service is dealing with that synchronous request is designed to handle it. You still have contracts between services, so even though you don't have API requests, you still got contract because the service that's publishing an event and the service that's consuming an event has schema that they both need to understand. So you need to look at things like contract testing to make sure that you're validating changes in the schema don't break how that would work. You need to handle event processing failures. So obviously, even if you still publish events, you can consume them, things can still go wrong. So you need to look at things like the letter queues, put in event tracing using X-ray, for example. And crucially, don't go big bang. So if you've got an architecture that's not working well and you know where you want to get to, don't go away for 6 months and rewrite code. Iterate and learn from small changes to your architecture. We're still learning how to do this well. We don't do, I mean, we're not even doing contract testing yet. So this is something we're looking at active right now, but something we're going to introduce in January, actually. So we're still learning how to do these well. It's still a learning process for us. So we've got some principles. How do we enforce these principles to make sure we're doing things the right way? I guess the answer is we don't. Why? Because it makes teams more autonomous. We've talked about the biggest benefit that we get from decoupling our architecture is that teams reduce the dependencies they have so that they can move faster and make those more autonomous. And if you enforce things, you tie them down. So if you enforce things and make them work in a certain way, you just tie them down, makes them less autonomous, which is the opposite of what we do. Yeah, and anyone who's had, I guess, experience scaling businesses will know that, yeah, if you give teams more autonomy over things, it reduces pain of scaling. This might contradict what I said earlier about letting things grow organically, but bear with me. One of the things we talk about in the office quite a lot is this phrase called adaptability over efficiency. So teams who have the freedom to adjust to the circumstances around them scale much better than teams who are quite aligned in how they work, but don't have the flexibility to change how they work. So our teams are free to build things the way they want. But we don't want to think things grow completely organically, so we have some principles. And we quite strongly believe in what the Agile Manifesto says about people and processes. And we make sure that our engineers understand the benefits of following principles and do that through people interaction. So we have regular workshops, we share ideas in guilds, we do a lot of carrying and coaching to help engineers understand the benefits of doing things this way. You can be free to do what they want, but we want to make sure they all understand what we're doing. So I guess coming to the end of my talk, there's a couple of things I want you to take away from what we've learned and what we're trying to practice. Autonomous teams move faster, they scale faster with less pain. So really, the key takeaway is to give teams autonomy, but encourage pollination of good practices and principles, and do this through people interaction rather than processes. I guess before I finish, does anyone know what that is? Has anyone seen that? Yeah. So that's Monzo's. It's actually taken from Monzo's blog post. It's a really great blog post on how they built network isolation for, I think they've got 1,500 microservices in production. The reason I brought this up is not to highlight if it's good or bad, but really highlight the complexity that's involved when you're really running microservices at scale, thousands of microservices. And if you really need to have principles in place to make sure that you can scale that well and have your teams working autonomously at that scale. So yeah, the takeaways from my talk is scaling is hard, but what makes it harder is the dependency between teams and their systems. So you really need to spend time thinking about your domain and service boundaries to allow your teams to decouple themselves. You also need to give teams freedom to make their own decisions about how they want to build things. You need to have a vision of what good looks like, and you need to come up with some principles to get there and follow them. Thank you.
So I understand the benefits that we gain from decoupling the services by using event-based transfer of state rather than querying via APIs. But one thing that I can't take my mind off is that we now have 4 copies of the recipe that is stored in 4 different places, and wondering whether that's brought its own challenges.
Yes, I think the biggest challenge is consistency of the data. So especially if you've got one of those, say, 4 services that's storing a copy of that data, hasn't been able to process the events that are coming through successfully, that service is quite out of date, and you can't rely on their data. But I guess you need to, it's not an easy answer, it's no science to it, it's an art, but you need to think about how you want your, I guess, the functionality that relies on that service, that's storing stale data, how you want that to work in a way that doesn't make it painful for the customer. Deal with. I guess one of the challenges of dealing with working with distributed systems is it's not just the back end. You need to have a customer-facing experience that also deals with the fact that your data might not be up to date.
Better than a broken API.
Yeah, it's better than not working at all.
Sorry, you mentioned the developer piece, and just curious about how in operational quality about monitoring those and who's keeping an eye on it.
Yeah, so we
actually categorize them. Oh, okay, this looks like it's important. We need to jump on this.
Should I let one of the engineers answer that? So we follow the philosophy of you build it, you run it. So our engineering team who's built that service with the queue that's consuming events, they are responsible for making sure there's LFQ in place, there's alerts on it. We've got a platform team that enables a lot of this functionality out of the box. So if you're using some of the conventions we've got on our platform, you get all of this for free. But again, engineers are free to do what they want. Like they can completely customize the entire automation stack that the service uses to do whatever they want to. But yeah, we've got automatic deadlift queues that come if you've got a queue that you want to use, and there's automatic alerts that we've got on top of that. So when it exceeds a certain threshold, you get alerted automatically. And the engineers who run that service, they're responsible for monitoring it and reacting to it immediately.
How do you go about publishing and maintaining these contracts between services? So you mentioned contract testing. What are your ideas?
So I think one thing we look at is a schema registry where you publish schemas that are used between services, and you can use that schema registry to run your contract test. When you push a new build and the schema is updated, you can run a test against that to make sure that the service is consuming it, the schema is still running it. Then there's tools out there like packs that I'm sure you will that allows. Yeah.
Right. Can I talk a lot about the benefits of using the asynchronous messaging over the synchronous calls and how that kind of avoids the issues of synchronous messaging, particularly for requests. But I suppose it doesn't cover up the fact or change the fact that the amount of services are talking to each other, they're communicating just in a different way. And I get the impression that there was lots of separation of microservices by entities, but in terms of domain modeling, it was less about aggregates or wider than that, aggregates that are shared at the same context. So things like, for example, the cookbook and the cookbook groups, do they really make them like 2 separate domain contexts inside the organization? Because when one of them is just consuming the other one.
Yeah, I think if
it's gone too far that way.
Yeah, I think if maybe it wasn't maybe I didn't explain it very well. I think that cookbook service that you were reading from, that's like just a read-only service. Then you've got, I guess, a service that manages data, so that's where you write to. So that's where say a person who's creating a new cookbook group, they'll go into our admin tooling and they'll create a new cookbook, add some recipes to it. It'll save there and it'll push, I guess, that cookbook or that group to this read-only service. And that's where I guess the front end will read from.
Okay.
But yeah, I get your point. Yeah, I think and again, it's not a science. It's an art to work out what your domain boundaries are and how you want to group entities together. So I mean, we probably don't have like dedicated entity services for everything. Some of them are grouped together. For example, we don't have recipes or ingredients separately at the moment. They'll group into one thing. Sorry, give me this.
Just a quick question about the data bulk coding, which I've not heard of before. So I assume that in the event that all the services receive, they subscribe to it, are you passing the entire payload of the data as well?
Yeah, so we don't. So so we use pub sub architecture, so the publisher of the event doesn't care about who's consuming it and what data they need. So the event that's published contains everything, but it's the consumer that's responsible for taking bits of that payload they need for their own specific purpose. It's just storing that data. So for example, if you've got a service that's just saying a list of recipe titles, that will take a recipe created message or event, and it will just take the title field and store it in its own database.
And what happens if a service suddenly needs some extra data? It doesn't currently have it locally. How do you deal with actually going away and getting all the historic data that you need, that it needs to, once you push that new version into production?
Yeah, so I guess with platforms like Kinesis Kafka, you've got, you can just rewind in time. And
But you're not using Kafka.
We're not using
So
Kafka,
how
so
do you
we've actually built our own thing to replay.
Okay.
So related to that, you get drift between the different instances, and that is not fixed by just publishing events.
What do you mean by
between the different copies of the data? Like if at some point one publisher fails, and it goes into a dead letter queue, like you start to get drift between the different versions. Have you had that happen?
I guess it depends why it's going into the letter queue. So if it was just a one-off and it went to the letter queue, but then you got a future update for that same entity, then it'll obviously update itself. But yeah, I don't know, maybe you can answer that because his team looks after the recipe, recipe data. But I'm trying to think of an example where
if it ends in the queue and the future updates, it will trigger, it will receive the future updates and update that entity. If you requeue the messages that in the letter queue and they are all, basically we skip that message and delete it from the letter queue because already updated with new updated data. That's what it does.
So if one of the microservices is not working well, I would say probably down. So how do you, or maybe it's like delay in that microservices. How do you debug that? Like which microservice is doing malfunction?
in what sense? Is it down completely or is it
Well,
slow to
maybe
process?
it's like producing too much delay in that. So how do you figure it out? Okay, which microservice is causing this delay?
So each service that's consuming events has its own dedicated queue, and you can put monitoring in the queue to see what the age of the oldest messages in that queue, so you can see how far backed up that queue is, and you can put alerts on that to see, I guess, how long it's taking to process.
So you say you could. So what you do?
What do we do?
Yeah.
We do that.
Sorry, folks, as much as we're enjoying this evening's questions, we do need to wrap the event up. We are going to go to the pub as we normally do, so if you do have more questions, then join us in the pub and that can be more of a discussion rather than keeping everybody in the room for questions. We're going to go to the Telegraph. If you come out of the lifts, you turn right as you come out of the gates, walk into the corner, you'll see there's a little alleyway there. Walk through the alleyway, the Telegraph is there. It looks dodgy, but it's actually a very nice pub. Sounds dodgy rather, it's a nice pub. And then there's just two last pieces from Dario and I.
Thank you, Albert.
Two last little bits. We're rebranding the Microservices meetup. It's not a big thing. We've literally changed from the previous hideous Honeycomb brand to the now slightly less hideous London Microservices. We've also dropped the user group to make it a little bit easier when you're telling people where you're going. Instead of going to the London Microservices user group, just going to London Microservices now. And the last piece of puzzle, if anyone in the room is sitting next to a woman, could you please put your hand up? And I think that obviously tells a tale. We are looking for speakers, and to all the ladies in the room, thank you very much for coming. And second of all, if you are interested in speaking at one of these events, please talk to Dario or I. Dario is brilliant at helping first-time speakers find their talk and build their confidence, be you man or woman. And if you are interested in speaking, one of the easiest ways for us to help improve this group is actually have speakers who don't look like either Dario or I would be a good start. So yes, definitely, if you're a speaker and you're interested in talking, feel free to speak to me, but Dario is the technical mind behind microservices, and he can help a lot more with the technical talks. Other than that, let's wrap it up, and anybody who's interested in any of those things will be in the Telegraph.
Sure.